we've covered the main core of section 1 already. I just tossed in another day just to get us good at it and show you a couple curveballs, like just a few different things they could do. But realistically, you already have the skills that you need for this section. All right. So let's look at golf club repairs. So the paint company makes custom built golf balls and can it competes in the $4 billion golf equipment industry. To improve its business process, Ping decides to study the time it takes to repair golf balls sent to the company by mail. The company determined that 16% of a random sample of orders went back to the customer within 5 days. Oh, were sent back. There we go. That should be an S. Ping examined the processing of repair orders and made changes. Following changes, 90% of a random sample of orders were completed within 5 days. Assume that each of the estimated percents is based on a random sample of n orders. We used the sample data to construct two 95% confidence intervals for the proportion of orders completed within 5 days, one before and one after the changes at Ping. The intervals are this and this. Find the size of each sample. All right, so this is a throwback to something we actually haven't done since chapter 8, okay? But again, I figure it's good to revisit this idea because it is something that can pop up as we get closer to the AP exam. So, looking at this, sample size. So they're asking us to determine sample size, okay? Now, in chapter 8, we talked about it in a slightly different context. We were using sample size to control the size of what? What can we use a sample size to manipulate and control? Does anybody remember? Uh, we can use sample size. Doesn't sample size dictate the margin of error? Isn't that one of the things that dictates the margin of error, right? How big the interval is? Does everybody kind of remember? Is that ringing a bell? Yeah, see? Awesome. So, this one had a sample proportion of 90%. What was its margin of error? If its center is supposed to be 0.9, how far does it stretch in either direction? What is that margin of error? 0.42. Either one, yeah. They said this one had a sample size, or was it 16%, I think you said? Yeah, 16%. What was its margin of error? If it's sitting here at 16%, what margin of error did this one have? Oh, I'm sorry. I see what you meant, Cole. I did do that wrong. You meant I needed the 0 there. There we go. That's better. What about this one? 0.16 up to 0.2 or 211. How long is that? Isn't that 0.051, I think? Yeah? So again, let's recall, how do we calculate this? Okay, so if I have my margin of error, isn't margin of error composed of two things, right? As I'm building my confidence interval, the margin of error is constructed by the critical value and by the standard deviation of the statistic, right? Critical value, where does that come from? Table, yeah. That critical value comes from the table. I'll just give it to you because we use it so often. 95% is going to be the 1.96. Standard deviation now, isn't this just based on one sample for each of these, right? One sample they took before, one sample they took after. So if we're using one sample procedures, isn't that right here, right? And it says we can use the proportion. Well, what's our best guess for the proportion? Do we have a good guess for what it should be? What the actual proportion should be? What's our guess for it that we could use? Yeah, after it's 0.9. before is 0.16. So wouldn't these two formulas, wouldn't these allow us to find the sample size that was used to create those intervals, right? So again, let's walk through that process, okay? Tell me what to do. What's the first thing that I would do? Divide over 1.96, okay? So I would have 0.042 divided by 1.96. What's the next thing I would do? Square it, all right? So the next thing that would happen is I would square it. How about next? What? I actually wouldn't do that. Does my variable do me any good in the denominator? No, so what might actually benefit me here? Yeah, if I multiply this up, so if I have my n over here, now how do I go back and get the n by itself? I divide by this kind of beast here, right? So when I do that, 0.09 divided by this thing, that's going to give me sample size of 196 for this one. And I would follow the same procedure over here, right? So I'm just going to do that one really quick for you so you don't have to sit here and walk through the same thing again. But wouldn't you agree it'd actually be the exact same mathematical steps to do that over here too, right? So I'm going to do this really fast for you. That one has a sample size of 199. All right, so is everybody okay with that? Right, just a little throwback to chapter 8, one of the skills that we covered back then. Everyone okay? Yeah? All right. So here, explain why we can't just subtract them. So they're trying to find a 95% confidence interval for the difference in the proportion before and after, okay? So what they did is they took their two samples, okay, made confidence intervals for both, and then just subtracted the smaller value from the larger value for each. Is that what we do to find a confidence interval for the difference? Is that what we've been doing this chapter? Finding two separate ones and then just subtracting them? Is that a thing? No, okay? Confidence intervals don't work that way, okay? You can't make multiple intervals and then just start subtracting them from each other. What we should do to make a 95% confidence interval for the difference, for that change, is we need to actually follow those procedures that we talked about last week, okay? So that's a mistake they made, is you can't just make multiple intervals and subtract them. You have to follow the procedures that we were going through last week. Actually follow a two-sample procedure. All right, so speaking of that two-sample procedure, let's walk through this example and actually do it the right way, okay? So now they want us to go back and actually construct and interpret a 95% confidence interval for the improvement in the proportion of orders sent back to customers. So this date step here, Okay. How many samples are we looking at? Two samples. Okay. So this is a two sample procedure. Since it's for proportions, what do we use? Is that a T or Z? Z. Okay. Yeah. That's for a test. Yeah. Which actually, our next example will be a test to remind you of that. So don't you fret, that's coming. All right. What? Move it up like that. I wouldn't on the AP exam. They won't know what that means. Or probably just to be so funny and I know what you mean, I probably actually would. All right, plan step. Let's check our conditions. What's the first condition we always check? And that's always kind of the easiest anyway. Random. So here, they did say that they took random samples of orders. For normality. How do we check normality? Actually, we don't even have to worry about expected because this is a confidence interval. So it's literally just successes and failures. Now, in this case, okay, um, in this case, actually, 199. Yeah. So here, how did I get that 32? Where are these numbers coming from? Because they weren't exactly given in the prompt. Where did I get them? Yeah, so here, this first one we calculated, we had 199 in our sample, right? 199 in the sample times the 0.16. That's where the 32 comes from. Okay, so those are just using the proportion of successes that we knew along with the sample sizes that we calculated. Okay, because successes would also be sample size times the sample proportion, failures would be the rest. And again, you do always have to explicitly state that all of those values are over 10. I remind you this a lot, that if you forget that, they deem that as just stating the condition, not checking your condition on the AP exam. So I am a stickler for that to make sure that you do include this piece right here. And then what's the last thing we check for? Independent. So both samples should have been less than all the golf clubs at that time, and the samples should be independent from each other. That is a reasonable assumption to make. What? Oh, that'd be lovely. To just be able to explain yourself and not have to write it all out. All right. Do step now. Again, in this chapter, we absolutely love the do step, right? Because isn't it honestly just picking the right program and then away we go? We don't have to show anything. So let's find our right program, shall we? So if we go to the list, okay, we named this thing as a two sample Z interval for a proportion. So remember, when it's for a proportion, it explicitly has to say proportion in its name, right? So we know it has to say proportion. We know it's a Z interval. We also know we had two samples, so realistically, there should be a 2 sitting out front of it, right? So let's scan to see. 6 looks close. Why is it not 6 though? It's a test, not an interval. Okay, excellent. So I'm going to keep scanning, keep scanning, keep scanning. Oh, is that what we want? Is that good? Yes. All right. I'm going to need your help with the numbers because I don't remember all of them. Let's go. old minus new. Okay, so give me or sorry, not old minus new, new minus old. So let's go after the improvements were made. So 176 out of, was it 196? All right. Is it a 95 interval we want, I think? Yeah? Okay. Excellent. And there we go. And remember, in our do step now, honestly, the only thing we need is that, right? As long as you've given this thing the appropriate name, they actually don't have to see your math. That is also true for one sample procedure. So when we go back and we're re-exploring one sample procedures, actually same story, okay? Again, I was just having you show me that for so long to make sure you understood how that would work for multiple choice. You don't need to do it anymore in any version of an FRQ. The one thing I do recommend, remember when we name it, after we run the program, remember I do like to go back here and clarify what that difference means, right? The difference we put in the new sample minus the old, right? It is a good thing for it to clarify how you organize this in your calculator, okay? Because it always takes the first thing you typed in minus the second thing you typed in. We took the newer sample and we minused off the old one before the improvements were made. Again, good thing to clarify for them. How do we conclude for an interval? We are 95% confident that the interval contains a true, and then isn't this just copy paste from their prompt, right? So for your sake right now, what I'd say is just get it started and then do like a little dot, dot, dot. Yeah. Because I trust you know how to do the rest when you need to. All right. So our next example, preschool programs. To study the long-term effects on preschool programs for poor children, researchers designed an experiment. They recruited 123 children who had never attended preschool from low-income families in Michigan. Researchers randomly assigned 62 of the children to attend preschool, paid for by the study budget, and the other 61 to serve as a control group who would not go to preschool. One response variable of interest was the need for social services as adults. In the past 10 years, 38 children from the preschool group and 49 from the control group have needed social services. Does this study provide convincing evidence that preschool reduces the later need for social services? So again, just noticing key phrases here. Does this study or does the data provide convincing evidence? What is that our prompt for? What is that telling us to do? Four-step process for a test. All right. So this is the language you'll be looking for to clue yourselves in that you're looking to run a full-scale four-step process test. All right. Once again, wasn't this two sample for a proportion, therefore a z? Oh. Oh my gosh, what have I done? Oh, nice. Yep. Yes, it is. All right, good news. Isn't the plan step the same as it was for the confidence intervals, right? So what's the first thing we check? Oh, thank you. What is wrong with me? It is a Monday. Thank you. Yes. For tests, we need to establish our hypotheses. Okay. Now remember, how do these two sample ones work? Instead of being equal to a number, what does it equal? Each other, yeah. So when you have two sample things, the null still uses the equal sign, but it's that your two things equal each other instead of equaling some given value. All right? So, actually, I could have just done that as pre-K instead of preschool. Whoops. Um, So remember also, if you use meaningful subscripts, you don't have to identify it separately like we were in chapter 9. Okay, so always use something that distinguishes between your two groups. All right, and here I really just should have done pre-K instead of preschool. So have yours pre-K. It's easier to write. And what do we think is going to happen? We're testing to see if there's evidence that preschool reduces the later need for social services. How is this going to change? Yes. So we're hoping the pre-K group should be less than the no pre-K group, right? We're hoping it's reducing the social services. If you have time, if you go back, help me pass those back, that'd be great. All right, now we can get to the plan step. All right, so to plan this out, what's the first thing we check for? Random. Now, we're used to hearing about random samples. Is that how they adjust their randomness here? Randomly assigned, yeah. These weren't random students selected. They were randomly assigned to a treatment group, okay? Either going to preschool or not going to preschool. So again, just always watch however they address randomness. All right, normality. How do we check for normality in Yeah, so success failures. Now, I love you're in the mindset of expected. But actually remember for two sample they kind of neglect that and they just let you roll with whatever was actually there, just like a confidence interval. So a little bit weird, but they actually do not make you do expected here. Because remember there really is no expectation per se, right? There's no value that we're specifically looking. Yeah. So that's why they say you just roll with whatever's already there. All right, now here's the little trick also. If we're not sampling, do we use the 10% condition here? Now, how do we justify independence if we're not using that 10% condition from sampling? There we go. We're going to say the random assignment is going to help create independence amongst our individuals, and then it also makes sense that the individuals or the two groups should be independent from each other as well. All right, do step. Well, again, do step super easy, right? Because all you have to do is find the right program. So this time we ran a test, right? We're doing a test on two proportions. Okay. Again, if it's for a proportion, it explicitly must say proportion. It is a z-test because it's for proportions. And we should be looking for the number 2 because there were 2 of them. Which one models, it's actually already showing, which one models what we need? 6. It needs to say proportion, it is a z-test, and because it's 2 samples, it explicitly has to say 2. All right, can you guys help me read off the numbers, please? The way we wrote it out would be kindergarten first, not kindergarten second. All right. All right. So looking at this again, the way you should type this in is the first thing you wrote in your null, and then the second thing you wrote in your null. And then we think that it should be less than, right? Isn't that how we set it up? Calculate this. So again, the only two things you need here are what the z test statistic is and what your p-value is. Literally all that you have to write down for your two-step now. That's a really great question. It's just something that makes their rubric, so I teach you to show it. Because anything that keeps the test graders happy, we do. All right, and that puts us right here. So, what would our conclusion be? We reject the null. Yeah, our p-value is small enough that we are going to reject the null. When we reject, what does that mean? Did we get the evidence or did we not get the evidence we were looking for? We did get the evidence we were looking for, yes. So here, because it's less than 0.05, we reject the null. There is evidence, and then isn't the rest of it just copy-paste from that prompt? What? Oh, that is totally okay. All right. Shh. Are you okay? Okay. All right. Now, let's look at this. So the mini-top output below gives a 95% confidence interval for that same experiment. Okay, so using this data, they constructed a 95% confidence interval. All right. And so what we're saying is we want to explain how this confirms what we did. Okay. So again, if we're talking about differences, what value represents no difference? What value represents the null? 0, okay? So the null represents no difference. The null represents 0 change, 0 difference. Is 0 within the interval? No. So the interval is confirming that we don't think 0 is it, right? We don't think it's possible to not have a difference. And isn't that why we rejected the null? So does that confirm what we just found? Yes. So here the confidence interval does confirm what we discussed in the hypothesis test. I said nothing. I can't take this. Oh my gosh. All right. Shh. All right. So, a study reported in the medical journal Fertility and Sterility Sought to determine whether the ancient Chinese art of acupuncture could help infertile women become pregnant. And 160 healthy women who planned to have IVF were recruited for the study. Half the subjects, so 80 of them, were randomly assigned to receive acupuncture 25 minutes before embryo transfer, and again 25 minutes after the transfer. The remaining 80 women were assigned to a control group and instructed to lie still for 25 minutes after the embryo transfer. Results are shown in the table below. Is the pregnancy rate significantly higher for women who received acupuncture? To find out, researchers perform a test of either the two proportions equal each other, so the rate of pregnancy is the same, or 1 is greater than 2, where P1 and P2 are the actual rates of pregnancy for those like the study who do and don't receive acupuncture. Name the appropriate test and check that the conditions for the test are met. All right. So here, we're not actually doing the full 4-step process. Aren't we literally just following whatever prompt they give us at any given point, right? So here, name the test. Well, what kind of name would we give this thing? Yeah. A 2-sample z-test for difference of proportions. And then they want us to check the conditions. So they already set up the hypotheses. They want us to make the conditions, to check our conditions, okay? What's the first condition to check? Random. Was this a random sample of women? No, it was random assignment, okay? So actually, I forgot to change this phrasing. A better way to phrase this is you could say they were randomly assigned to a treatment group rather than just saying that this was an experiment, okay? That'd be actually a better way to phrase this, that they were randomly assigned to a treatment group. Normality. How do we check for normality? Successes and failures. And here, actually, considering it's all in the table, isn't it really nice because they gave us all 4 numbers that we needed? And if we're not sampling, are we going to use the 10% rule down here? No, what do we use to justify independence if we're not actually sampling? Because then we don't need the 10% rule. Random assignment. Yeah, the random assignment is what's going to create independence for these groups. All right. So the appropriate test from part A yields a test statistic z equals 2.164. Find the p-value for the test and interpret the p-value in context. All right. Now here, so they give us basically a z-score. They want a probability, and didn't we just say that this thing is normal? So remember, when we're in this circumstance, given a test statistic, okay, a z-score, we want a probability, and we know it's normal because we're running a test on it. What can we use to find that? Normal CDF. So this is a case, normal CDF is going to pop out that p-value for us, all right? So go into distribution, normal CDF. It was 2.1 what? 64, all right. Do I need to multiply it by 2? No, because this is a one-sided test, a one-tailed test. So this time what the calculator gives us is legitimately just what we want. All right. So 0.0152. Now, what it wants, though, it also wants us to interpret this, right? Remember, how do we interpret a p-value? That's concluding. Yes. Yes. So when we're interpreting this p-value, okay, when we're interpreting it, so we're talking about if there really is no difference in pregnancy rates, there's only a 1.52% chance of seeing as many or more pregnancies while receiving acupuncture as we did. Okay, so talking about seeing a rate at least as large as ours of pregnancies versus no pregnancies. Oh, that should be for, not or. Sorry. All right. What conclusion would we draw here? We would reject the null. Okay. So because our p-value is less than 0.05, we reject the null. What does that mean? We have evidence. Yes. All right. Now, so we just rejected the null. What type of error could we have possibly made? We could have made a type 1 because type 1 addresses rejecting the null, but that could be the wrong decision. Well, that's the only thing that could have happened to us, right? Because we did, in fact, reject the null. So the question is, what if that were wrong to do? All right. And then one multiple choice question, and then we will be done for the day. At a baseball game, 42 of 65 randomly selected people report owning an iPod. At a rock concert occurring at the same time across town, 34 out of 52 randomly selected people reported owning an iPod. A researcher wants to test the claim that the proportion of iPod owners in these two venues is different. A 90% confidence interval for the difference in population proportions is that. Which of the following gives the correct outcome of the researcher's test claim? So before we start reading all of this, let's see if we can decipher what we're looking for from the get-go, okay? Sometimes I honestly believe that is a great strategy. Have an idea what you're looking for before you start reading answer choices. So he's testing for a difference. Well, what value represents having a difference or not? 0. 0 in this chapter is that magic number we're always shooting for. 0 represents if there might be a difference or not. Notice, is 0 in the interval? Yes. Okay, so let's process this. So 0 is in the interval, which means we do believe it's possible that there's no difference, right? Is everybody with me? So if we believe it is possible that there's no difference, would we reject the null? No. So we would fail to reject the null and say we don't have evidence that there is a difference. Is everybody with me on that? All right. Now that we have that established, I want you to tell me which one is the proper choice. Which one sounds like what I just said? Yeah. It's the subtle difference. Yeah. Yeah, so actually, actually, that is a very, very good point. Don't A and C both sound right? The subtle difference is C has better language. C is in the language of failing to reject the null instead of A, which sounds like it is accepting the null. Does everybody see that subtle difference there? Right? You want it phrased as failing to reject, not accepting. Okay? So, yes, C is the better answer here. Yeah, so I actually ended up realizing why I took one off, and that was actually, so what's wrong is you have one of these two, so one-sided piece would be this is a two-sided, so that would be the one. So what's the alternative? And then being angled the wrong way. Remember, there's always two possible ones if you're going back and down. So it would be this, and then one minus this. Because what if the alternative had been angled the wrong way? Then you would need the opposite. Look at this. So yeah, so if you do that, then I can give you that point. Okay, now AJ. Now, guys, again, I know we had this conversation before. And you guys do well, but when it comes to these fields, being smart isn't always enough, right? I told you before. I use essay, and that ends today, so you need to do that today. Yes, you do. Now, again, just keep in mind, my goal is for everybody to sign up and pass. Okay, that is my goal. That's what I want for everybody. At the end of one, that and that's for college credit. Just so it's when we have people taking higher credits, you guys are taking that and they deserve their best. It's like just like you guys deserve your best. So what I mean what time do we get out? Okay, and I know it's hard to spring. Like honestly, I really do know to put a bar cover as to whether it's nice. And it looks nice out. I know it's hard to focus. But again, I can't guarantee the college credit for people who aren't willing to stick with me. Okay? So if you make that commitment to take the test every single time today, I also need you to make the commitment that you need to focus on your classroom and make sure that you do. Because again, people around you deserve that, and you deserve that if you want the college. Is that fair? Are you kidding me? Does it make sense for you? Okay, so can we work on this respect thing? Oh, okay. Yes. should write it on my calendar, because then I'll remember. It felt nice though.
We either have our drum line, we have our guard horn, which is like a bunch of guards, color guards at 1, or we have our drum line on at 5:30. The drum line one tends to go late, and it hurts my ears. So I recommend the guard horn.
Is that the first one?
Yeah. Yep. You'll see all 3 of the upper groups no matter what.
Oh, perfect. Love it. Because I'm so Oh. Okay, that video is so weird. You're a wizard, Harry. Have a great day, everybody. Oh,
Oh, I'm so tired.
I am too. It's actually a full school week. How weird is that?
Yeah, that's gotta be what's going on.
No one's used to this.
It's supposed to rain like all winter, so it's just gonna be weird.
I mean, I
I'd
guess
rather
that's
that than snow though.
right. I'll say at least that's better than snow, I guess.
And that should, I don't know. Hopefully this just goes away quick.
I mean, the issue is if it goes away too quickly, we're gonna have flooding. But I feel like either way, we're gonna have flooding. So I'd kind of rather
Yeah, I
just
think it's either just gonna like not be as much at one time, but it's gonna be like prolonged sort of.
yeah.
I don't know.
I just want this gone.
Yeah, it's not fun to look at.
No. Of course, like you probably hear me talking with like Adrian and them that it's like actually I know our focus gets worse the nicer it gets. So
Yeah.
imagine what everyone's gonna be like when it's actually nice and spring like out.
I'll bet you $100
That's gonna be-
AJ starts chanting class outside because we did that last year in English. We had a sub. She's like, yeah, okay, we can go outside.
Oh God.
Yeah, it was weird.
All right. Well, have a great day.
Yeah, you